Hi everyone, welcome back to our tutorial. So previously we learned about probability, and there's a student asked me about why the equation should minus PA plus PB should minus PA and B. So imagine that if they are individual, I would like to know PA or PB, all right? So I just add PA plus PB. When I want to, if they are overlap, okay, can you see that? The blue color overlap with the yellow color, right? So what happened? What happened is, if you count PA or PB, so there is a overlap between A and B twice. It's just like this example, okay, that we discussed last week. If I look at too short, okay, I have a 5 among of them are too short and too thick. Well, when I look at the too thick, and I have 5 among of them are too thick and too short. So it seems like I counted twice on this part, and therefore I should remove the one time too thick and too short. All right. So do you understand? Do you okay? Much okay now? So Bayes theorem, also there's one student confused on that. Okay, Bayes theorem is actually, I would like to know the probability F happened first and then E. But the information that I gather now is E happened first, then F. So in this case, what should we do? Okay. So we know that using the conditional probability, PA stroke B, okay, we know PB first. So at the bottom is PB, and at the top is PA and B, okay? For A first, then B, this is B first, then A. For A first, then B, all right? So what happened is, because your A first, then you are using the PA at the bottom, and PA and B at the top. And we also can move this equation to become PA and B is equation 1 and equation 2. Well, if you look at the Bayes theorem, all right, so it seems like for example, I have PA stroke B. In this case, which one first? B first, right? And I would like to know, and given that in the equation, the formula, I have P, B stroke A. So in this condition, what should we do? Okay, so first, we know that PA and stroke B is this equation. Okay, right? And given that the question given the other information, right? So, and therefore, you can use conditional rules, okay, conditional probability to find your PA stroke B. Okay, it's quite clear now. Okay, so next, let's look at the question, our tutorial. Well, let's go to, let's try. Okay, this one I think we discussed before, but we can check again together. The customer who purchased a certain make of car can order an engine in any of 3 sizes. Of all cars sold, 45% is small engine. So the medium engine is 0.35. The large is 0.2. So they are all engines. So I label them as A. So the A1 is small engine, A2 is medium, A3 is large, okay? Of all the cars with small engine, so given that the small engine, okay, and 10% fail emission test. So given that A1 is fail the emission test is 0.1. Given that the medium one fail, the B fail, given that the medium size and 12% fail, given that it's large engine and 0.15 fail. Okay, so what is the probability a random chosen car will fail an emission test with 2 years? So another question, another words means, what is the failed emission test? Okay, first, you can draw this graph. It can be circle or square or rectangular. And among all the car, there is a small portion that they are fail. That involved is small size, then small that involved in medium size and large size. Okay, so it seems like we have 3 parts only. So we don't have part 4. Okay, so let's see if I can move it. Okay, I think that would be better for you. So in order to get the PB, I know that it's involved PA and B, PA1 and B, PA2 and B, and PA3 and B. Okay, so, and I also know that with the conditional probability, okay, the conditional probability, PA stroke B, PB is equals to PA and B. PB stroke A, PA is also equals to PA and B. So well, so now we go back to our example. Where's our try? Okay, so we know that we can replace this as that because PB stroke A1 is given. So we can use this to replace the PA1 PB, PA2 PB. Okay, so when you put it in, it seems like all the information is given. And therefore, you can get 0.117. Is that clear? Okay, so let's have a look on the try A. Okay, so there is a gift basket department. You can choose either to have cookies with coffee, mug with coffee, candy with coffee, or wheels with tea. Find the probability that if one basket chosen randomly, it contains coffee or candy. Coffee or candy. Okay, so it seems like very obvious. Coffee, okay. Candy. The selected one is the involved one. Okay, first one, I should find the probability of coffee first. Is 43 over 77. Probability of candy is 22 over 77. Minus, because there is overlap, right? Remember that concept? Minus 10 over 77. And you should get your 0.72. Try it out. Number 2, if the one basket is chosen at random, it contains tea, given it contains mug. So if we know that mug first, then is tea, right? So we know that probability tea and mug over probability mug. Tea and mug is 10. 10 over 77. Probability of mug, so 23 over 77. Check it out. So you have the same answer. Number C, if the basket is chosen randomly, it contains tea and cookies. Oh, that's so simple. Tea and cookies, 12 over 77. D, if 3 baskets was chosen at random and not replaced, so after you take it out, you won't put it back. All the basket contain marks. So if all the basket contain mark, among 23 out of 77, so you take out 23 over 77, right? This one, right? And then the next one is 22 over 76 because you took one out. And another one, the last one, 21 over 75. So that's the answer. If 3 baskets are chosen at random and not replaced, none contain mark. So what is the probability? None contain mark is 77 minus 23 is 54. Okay, the first one is 54 over 77 times 53 over 76 times 52 over 75. F, if 3 baskets are chosen at random and not replaced, at least 1 mark. So the E is none. So if I'm 1 minus, so those are the one that at least have 1 mark, correct? So you know the answer of F. That's all. It's quite simple, isn't it? So we try one more time. Okay. An automobile insurance company divides customer into 3 categories. So good risk, medium risk, and poor risk. Basically, they are risks, okay? Assume that 7% are good risk, 20% medium risk, and 10% are good risk. So I try to label all the risks. So A1 as the good risk, medium risk is A2, poor risk is A3. Assume that the course of the year, a good risk customer has probability of 0.005 of filing an accident claim. So assume that during the course of the year means that given that A1, okay, A1, they are good risk and they still file a claim. So it's 0.005. A2, it's medium risk, is still given that and it's still file claim 0.01. Poor risk, okay, A3 given and has the claim. So you have 0.025. Okay. What is the probability that the customer is good risk and file a claim? Okay. The A. What is the probability good risk and file a claim? So A1 and C. So we know that A1 stroke C stroke A1 is probability C and A1 over PA. So we have the P1, we have the C stroke A1. So we're able to solve it out. B, what is the probability that customer file a claim? So file a claim, you have the red color shaded part, we have the green color, and we have the blue color. So we can use the conditional probability rules to replace it, and then we can solve the answer. C, given that the customer has a file claim, okay, what is the probability that the customer is good risk? At this point, okay, given that, when you have given that, we know that C first. Okay, C first. C first. Given that is good risk, so it's A1. So we use the conditional probability rules and we can have probability A and C stroke probability C. Okay, so I hope you can try on this part So I'll see you next week. Thank you.